Well, very good afternoon, everyone. This is Martin Lush from NSF Health Sciences, the Pharma Biotech division of NSF. Very warm welcome to you all for the last of our 2015 free webinars. Doesn't time fly when you're having fun? Anyway, for those of you that haven't met me before, very briefly, I'm president of the Pharma Biotech division of NSF. Also a microbiologist. All those years ago, my microbiological career started off in the National Health Service in medical microbiology, working for a good 10 years in pathology, which is fascinating, scary at the same time. When you see what microbes can do to people, really is quite shocking. I spent 3 years in microbiological research, essentially looking at preservative systems in non-sterile products, cosmetics and the like. So I've looked at microbiology from a non-sterile perspective. And then finally, in my area of expertise, which is in sterile manufacturing, obviously challenged by keeping bacteria out of your products. So I guess the theme that has run through my entire career has been one of bacteria. NSF, interestingly, started off in 1947 with a mission to protect the health around the people, health of people around the world, and its business actually started off in the field of water with the objective of ensuring that people had a safe supply of drinkable water. And obviously our focus and the focus of our webinar program for 2015 has been on helping clients do the basics very, very well. What's really interesting, if you look at the product recall data issued by the regulatory agencies, if you read journals like the Gold Sheet, one thing that always seems to be top of the list of regulatory concerns is microbial contamination, whether it be of sterile products or indeed non-sterile products. So this is a war that we continually rage against bacteria, so to speak, because as soon as you drop your guard, as soon as you assume that you've won the battle, you've lost the war. So one of my objectives really is to make you aware that in doing the basics really, really well, you need to understand where the bacteria come from and to really keep your guard up when it comes to ensuring that these organisms don't get from their source into your product. So this is the last of the webinar program for 2015. We will be running another program next year, so that will be published very soon. As with all of the other sessions, ladies and gentlemen, this is being recorded. You will have access to it for you to use as you see fit. So, you'll get the details about accessing the webinar as soon as we've completed. And as with all of them, I'd really encourage you to spread the word, because really the more you share this information, the more people will benefit. I will answer all of the questions that you put towards me. I can't, unfortunately, answer them during the session. I can only do one task at a single time. So any questions that do come through, I will get back to you and then arrange a call so that we can actually do your questions proper justice and answer them fully rather than quickly in the time that we have available. This is just a flavor, really, of the expertise and understanding that we do have within NSF. There's a lot more competent and up-to-date microbiologists in our team than myself, but we do have real strength in depth when it comes to contamination control, contamination risk assessment, troubleshooting, and the like. But the one thing I will say to you, it is far easier preventing contamination than reacting to it. And really the objective of this session, ladies and gentlemen, is to give you some essential guidance on how to prevent contamination in the first place. Because frankly, once you've got contamination, once microorganisms are established in your facility or in your process, they are incredibly difficult to remove. Sometimes, in fact, impossible to remove. So, key learning objectives, really, number one, to consider the environments in your facilities that can serve as reservoirs of microorganisms and microbial contamination. And also to relate some of the theory of microbiology to reality so that we take it out of the microlab into the production facilities. I always say to microbiologists when I audit labs or audit companies where they do have a microbiology function, I always say to a good microbiologist that they should be spending 80% of their time outside of the laboratory, 20% inside the laboratory, if they really want to add value, which is really to prevent contamination in the first place, rather than counting plates in reaction to the incident afterwards. So that's something to bear in mind with your own microbiology teams. How closely do they work with you to ensure that these reservoirs are identified and removed before they cause you a problem? And the last objective really is to understand how to minimize the threat from microorganisms to contamination of your product. As I said, we consider there to be 4 essential reservoirs or habitats where microorganisms can exist. And once you understand these, you can then take steps to realize the critical control points, what needs to be controlled and how, so that you actually prevent the organisms getting from the reservoir into your product. So I'm going to look at each one of these. You have the atmosphere, that's your air and the plant environment. You also have a terrestrial habitat, which is largely the structure and surfaces and materials of your plant. You have, we use more water than most industries, so we have an aquatic habitat, that's your water systems. Anywhere, in fact, where there is a moist environment, and particularly at risk are products that are made up more of water than anything else, and that accounts for a lot of pharmaceutical products. And finally, and most importantly, people as a reservoir for contamination. When we look at some of the numbers and type of bacteria that we each generate, it's quite horrific, really, when you start to consider the levels of contamination that we're each carrying around inside us. So we're going to look at each one of these and actually ask the question, what organisms reside in each habitat, and what things must we control to minimize the contamination in each habitat, and in particular minimizing or disrupting the route of contamination. That's how they get from source into product. Sandra, I'm glad you got sound now, that's good. Let's start then with the atmospheric habitat. Our plants are surrounded by air of different qualities. If you're in sterile manufacturing, you know and are familiar with the classifications of A, B, and C. If you're involved in non-sterile manufacturing, we still have controlled areas of manufacturing, not necessarily classified, but certainly controlled, with the objective of ensuring that air is not a risk of contaminating your product. Air, interestingly, is a really hostile environment for microorganisms. There's exposure to UV that has a damaging effect. The air typically is very dry, and there is very little food source within air. Now, for microorganisms to survive, let alone prosper, most of them, not all of them, but most of them need lots and lots of water and varying degrees of nutrition. You remove either of those and you actually take away that organism as a contamination threat. But nonetheless, what can we expect to find in the air as far as bacteria are concerned? Well, we certainly find organisms like Bacillus species, and Bacillus is a gram-positive. That's a very sort of dark purple organism once it's been stained by gram stain. A Bacillus like organism. These, not all of them, but some of them can form spores, which are their mechanism of dealing with lack of moisture and lack of food. In other words, very hostile conditions. These organisms respond by creating a spore-like structure that makes them more resistant. So these bacillus and spore-forming organisms are pretty widespread in our atmosphere, as well indeed are some non-sporing gram-positive or purple bacteria, and there's a few there listed. So, if you were to place settle plates in your production environments in uncontrolled areas, these are the types of organisms that you would expect to see. So they are there. You don't find a broad range of organisms because of the hostility of the environment in which these organisms are being asked to survive. Importantly, they don't survive alone. They actually require a means of transportation. So this is when they attach onto skin scales, skin particles. It's when microorganisms attach to water droplets and dust particles. This enables them to transfer and move around that environment. So the influencing factors when it comes to levels of contamination in a atmospheric condition are things like the levels of activity. The faster people are moving around, the greater the contamination they're generating, how physical the various activities they're conducting. Obviously, the quality and standard of clothing practices, and importantly, the standard of housekeeping. Now, as an auditor, I always have a sort of zero tolerance for the last two. That's poor clothing practices and poor housekeeping. The number of times in a non-sterile production facility or in a packing line where you see, hats not being worn correctly, snoods not being worn correctly, and overall the standard of dress discipline pretty poor in reality, often because people don't understand the importance of good clothing practices in preventing lots of contamination coming from us as bodies, as people, into the production environment. And the same also is true of housekeeping. The higher standards of good manufacturing practice, in other words, housekeeping in particular, the better the microbiological control. So an area that looks clean probably is going to be cleaner than an area that looks out of control or very, very dirty. So one of the best forms of monitoring for bacteria actually is constant vigilance when it comes to those last two, good clothing practices and good housekeeping. So if you have production supervisors who are really hot on housekeeping and hot on clothing practices, you will have an environment that probably is under good microbiological control. So what happens to atmospheric organisms? Well, organisms in the air eventually settle, so those horizontal surfaces are more prone to their contamination, and the rate at which they settle are determined by the particle size that they just happen to be attached to, humidity. The higher the levels of humidity, the faster they settle, and obviously the air currents and air changes within that production environment. So this is where air change rates, this is where control over humidity, all of which, as we will see later, are functions of the HVAC system, are really, really important. As indeed are the levels of sanitization and cleaning, because this is what we rely upon to keep those levels of bacteria in control when they do actually settle on those horizontal surfaces. So none of this is surprising to any of us. The essential controls that minimize the atmosphere as a source of contamination are anything to do with our HVAC system, whether it be airflow patterns, whether it be temperature and relative humidity, whether it be air cleanup rates. Anything that disturbs the performance of the HVAC system has a knock-on effect to our levels of contamination. Often this is forgotten. Often when there's an increase in production output, when more people need to be in a particular environment, in a particular production room in order to get the batches out, that creates additional levels of contamination. So whenever you increase activity, you have to recognize that there will be an increase in the levels of contamination, and therefore we are duty bound to take steps to minimize that contamination by, for example, extra cleaning or extra disinfection. So greater activity, i.e. more people, equals higher levels of contamination, the significance of which will depend upon the activities that you're actually involved with and the level of exposure that product experiences in that production environment. Obviously, the warmer, the more humid the production environment, the greater the level of what we call shedding, which is when people lose skin and with it the millions and millions of bacteria present on those skin. On the skin. So it's not unusual when I work for clients in climates like Singapore or parts of India where temperatures and humidity can be very, very intense. You expect to see higher levels of contamination unless the HVAC system and clothing practices compensate. Clearly, levels of containment for product are key. Whenever product or components that come into direct contact with product, when they are exposed, you expect a level of risk. So simple containment levels, or indeed anything that minimizes exposure of either products, materials, equipment, or people, has to be good in reducing the risk of those organisms, those microorganisms getting or coming into contact with your product. Discipline and attention to detail for cleaning and disinfection is really, really key. Now, I emphasize this because cleaning is not a job most people like doing. It is often one that is contracted out to, unfortunately, very poorly skilled people that don't always get the training that they need. But cleaning and disinfection, when done well, is a key part of the armory in reducing contamination. So this is an area that is often just seen as an inconvenience, as a tough job that nobody likes doing, but actually it is vital no matter what product you're engaged in manufacturing. And obviously good clothing practices are key as well. But those last two, good clothing practices and cleaning and disinfection, because we do these day in and day out, poor practices, poor cleaning, poor clothing practices often gradually creep in, and before you know it, you have a contamination problem. So the vigilance and discipline enforced by first-line managers and supervisors is really, really, really important, because once you let standards slip, that's when you start to see microbial contamination coming through. And when you start to see poor environmental results or contaminated product, that is probably the result of months and months of build-up of contamination. When you get a failure in the test in the micro lab, or a failure of your monitoring plates that many of you will use for routine monitoring, that often is a result of weeks, if not months, of contributing factors not being addressed. So just bear that in mind. For those of you in clean room manufacturing, we know we have laminar airflow units that bathe our products and our exposed components in what really amounts to sterile air. And the airflow patterns in those areas are really, really key, which is why we pay particular attention to the validation and qualification of these units to ensure that that air is being swept out of the production environment away from the product, taking with it the microorganisms that have attached themselves to particles. So that's the plant environment that can contribute to contamination. And let's move on to another part of the plant, what we call the terrestrial habitat, which is really your buildings. So this is your walls and ceilings and any of the surfaces associated with the production environment. Walls and ceilings, certainly on these surfaces, you will have molds. Plaster is a great source of nutrition for molds in particular, and when you have poor ventilation, which often increases the level of moisture, you will often get an increase in the level of molds as well. You know, if you go to hotels as often as I do on my travels, you go into bathrooms, you know, you look at shower curtains and it suddenly becomes very clear they have a ventilation problem, because those dark molds of aspergillus are either on the tiles or at the top of the ceiling in the bathroom, all indicative of lots of moisture and poor ventilation. So the essential controls are really common sense controls, but common sense does not always translate into common practice. You know, the GMPs make it very, very clear to us that surfaces have to be smooth, they have to be impervious, they have to be washable, and they have to be intact. So whenever a surface is damaged, it has to be repaired immediately, because as soon as either exposed wood or indeed plaster starts to absorb moisture from the environment, that is when molds start to take off, literally, an increase in number. It's when bacillus start to germinate from their spores and cause environmental control problems. So, you know, if I had $1 or euro for every time I saw, either in a packing area or in a non-sterile manufacturing area, a damaged door, you know, where people have, you know, taken pallets and just damaged the door through direct contact, I'd be a very wealthy person. Because as soon as those surfaces remain undamaged, it actually communicates two things. It communicates a risk of microbial contamination for the reasons that we described, but it also communicates to people that GMP doesn't really matter, because if it did, those surfaces would be repaired. And obviously the emphasis on all of these surfaces is on regular and proper cleaning and sanitization. And remember that sanitizing agents are only effective on clean, dry surfaces. So often in heavily contaminated areas, a detergent wash is required before, in other words, to remove any grease and substantial dirt, before applying what we would know as a general disinfectant. So often people apply disinfectants or sanitizing agents to dirty surfaces, convincing themselves they're actually working. In fact, for most at least, they do not, or are not. None of this is new to any of us. You know, this is what a good production environment looks like. This is what coving in the ceiling on this occasion looks like, all designed to minimize risk of contamination, importantly, through having the surfaces intact, but also allowing a surface to be cleanable and for corners to be reached. Now, this is all pretty basic. However, you know, as budgets get cut and as many companies take on contractors based purely on price rather than quality of work when they come to a new build, you often nowadays don't see this level of attention to the detail required. Obviously, piping going in, flush fitting, similarly stainless steel gland plates for multiple pipe penetrations. You know, this is a new facility, so looks really, really good, but it's after the facility has been in use for many weeks, many months, that you start to see sealant around these plates start to wear and tear, particularly aggravated by the cleaning agents that are used. And the point really here is to ensure that housekeeping audits are a regular part of your contamination control plan. And I mean regular, whether it be daily, whether it be weekly, absolutely minimum, because as soon as you start to let standards drop, people get used to those standards and they become eroded over time and time again. So top of your list of priorities is really to make sure that you have a good housekeeping self-inspection program that makes sure that just as standards begin to drop, they are actually reinforced and improved. Don't forget compressed gases. For many of us, these are a component of our manufacturing process because they do come into direct contact with the product. Bottle gases are typically low risk, and the controls are those that we would expect for components of this nature. So, not forgetting drains and wash bays. I can remember many, many years ago a client saying to us, why are MHRA, our own regulatory agency, so interested in drains, Martin? Apparently every MHRA inspection they had involved the inspector looking at drains. Well, they do that for good reason, because drains are a key reservoir of bacteria, in particular in areas like wash bays, and the controls that we have to apply in there day in and day out, all are common sense, but not always common practice. These floors have to be cleanable, they have to be impervious, they have to be undamaged, they have to be resilient, because these are high usage areas that get a lot of wear and tear, and often don't get the love and attention that they deserve, particularly when damage occurs to surfaces. So wash bays in all of these areas where moisture is an issue, we really need to be very diligent. And in those areas where we are washing contaminated equipment, obviously we have floors that are sloping so that there's no accumulation of water, no puddles forming. Usually these are negative pressure to the rest of the environment so that they are containing contamination rather than spreading contamination. The drainage channels that are usually open to facilitate good cleaning, you will find organisms like Pseudomonas and Klebsiella, the waterborne organisms. And this is where housekeeping audits need to be done to ensure that these drains are regularly sanitized, they are kept as dry as possible, that there's no blockages, so that these organisms don't get the opportunity of establishing themselves. And vigorous cleaning and sanitization. These are not the most salubrious parts of production facilities. They're often ignored. These are the areas where lots of dirty, heavy work is done. And yet the number of wash bays I see with damaged surfaces, with equipment that has been cleaned, sitting alongside equipment that is being cleaned with all of the aerosols potentially recontaminating the equipment that has already been cleaned. So it is common sense, a lot of what I'm saying, but often these standards are eroded through complacency and through not really paying attention to the details. Again, common sense, good quality coving on flooring to actually protect the environment. Bob, you're asking a lot of questions here. I'll just take a few of them as I go through here. Bob Johnson has raised some interesting questions here. And Martin, I think it's very clear that people have a different perception between work and what they do at home. I try and highlight, what you do at home and what you do different at work. I think that's a really good example there, Bob, because a lot of what I see in production areas, I know people would not allow to take place in their own kitchens. We all know the risk of food poisoning. We all, if we're cooking, if we're preparing raw meat, for example, we all prepare that, on a separate surface, on a separate board or plate, which is then washed, and we use another board for, preparation, let's say, of fruit or vegetables. So a lot of what I'm saying here is actually common practice, as Bob highlights, at home, and it's simply making sure that people translate that common practice into the workplace. Although, sometimes it's actually not common practice at home, but it's really in communicating the importance of this to people. What Bob raises is really interesting, is to draw similarities with what people do at home and what they consider to be acceptable to what they also do in the workplace. Things like doors, windows, and fittings are all potential microtraps. It goes without saying you avoid the use of wood, because when that becomes damaged, moisture can get in there and out pops the molds that are just waiting to be activated. Sealed, high gloss finish, damage-free, damaged pipe lagging will create molds, all of which would be detected in a good housekeeping audit. In fact, before then, you are very reliant upon people when if they've damaged a surface, to actually raise that deviation so that that surface is repaired quickly, rather than even waiting for a housekeeping audit to spot it. So, this is where giving people, in the education and training you provide in microbiology, making them aware of the basic organisms, where they come from, what they need to survive. Much of this material, in fact, that covers how those organisms get from source into the production environment and, worst case, into your product, is really, really important, because once people have that appreciation, they become more aware, so that when they do see damaged surfaces, when they do see pools of water in the wash bay, or they do see blocked drains, they actually react immediately, rather than waiting for an incident, a contamination incident, to actually occur. In terms of the equipment, there's a real risk of contaminating product, particularly when equipment is poorly designed. And I make that point, and I emphasize that point, because so often as budgets are being tightened, it's very easy for us to go to cheap suppliers of equipment, cheap contractors to build our facilities. You actually get what you pay for, in my understanding. If you buy cheap, you actually pay considerably more afterwards. So poorly designed equipment that is not sanitary in its design, will cost you many tens of thousands of pounds or dollars or euros later. So equipment that is easily dismantled and cleaned. Always be aware of gaskets, and particularly if you're manufacturing liquid and cream products, where these products can seep in behind the gaskets and just sit there, gradually accumulating numbers of bacteria. Obviously, smooth and continuous surfaces are common sense, no inside threads, and valves that are sanitary, for example, diaphragm valves, although we all need to be mindful of pinhole leaks that are a result of the physical operation of those valves. Butterfly valves are not sanitary, and also present the risk of residue accumulating, and we all know that ball valves are not good enough because they are unsanitary. With pumps that we use in liquid processes, cream processes, pumps that we use in water systems, or present a risk if poorly designed, poorly maintained, and poorly operated of contaminating products. So, pumps that make sure there's no what we call dead volumes, that's residue or product sat there. Make sure that these pumps are easy to dismantle and therefore easy to clean, that they are self-emptying, so the last cycle on the pump will automatically empty rather than fill. Your maintenance engineers need to be mindful of checking the glands and drives for leakage, and making sure that they're sanitized, and also making sure that when pumps are in parallel, what we call duplex pumps, the material, water, product, whatever it happens to be, is actually running through both pumps, because if they're not, then you have the potential for a dead leg. Agitator blades that are very common, essential in fact for liquid processes, single piece, cleanable, always preferably clean in place, sterilize in place rather than manual, and always avoid bottom impellers. The adequacy of CIP and SIP obviously comes down to design. Well designed, not a problem. Poorly designed, CIP and SIP won't be effective. Pipelines that we use to move product, move water, minimal welds and joints. This is always a reminder to QA who often insist, or validation specialists who often insist on extra sampling points just in case. Well, every sampling point needs a weld, and every weld creates an opportunity of microbial contamination. So the fewer the welds and joints, the better. Obviously, surfaces that are smooth and internal. And just because the weld looks good on the outside does not necessarily mean that it's good on the inside, which is why we inspect welds to ensure that that is the case. Self-draining and making sure that flow rates are aggressive to create turbulent flow, so that the risk of dead legs is actually minimized. Dead legs is really whenever there is the risk of static water or static liquids or creams building up, because as soon as you create that environment, you create the risk of microbial contamination. Just going back to some questions here that Bob's asked. Also, when you transfer cold stored equipment into a processing area, the level of condensation and droplets on the floor can lead to unexpected contamination. That's a very good point, Bob, that whenever you have significant differences in temperature, you get condensation. Often this is the cause of molds in blister packs of tablets, because the bulk tablet has been stored in a fairly cool warehouse. If it's then transferred to a very warm production environment, that condensation on the inside of, because these are usually put into polythene bags, the condensation then increases the moisture of the tablet. That's not detected in all cases, and then when the patient opens the blister, you see this big hairy black mold appear as a result of that. Ramala, you asked a question here, going back to the wash basin. How would you recommend to dry hands after washing, using electric hand dryer, or would you prefer towels? Well, that's a really interesting question, Ramala, there. I've never seen any data to prove either is more effective than the other. I'm sure the data is present, but I'm quite relaxed either way, because it really comes down to how effectively each is used, and it really does come down to how adequately people dry their hands and wash their hands, and how adequately they use these electric dryers. You see the electric dryers being used more commonly in public conveniences. So whether that's an indication that actually they're more effective, I don't know. But it's a very good question. I've never seen any data that indicates one is better than the other, because actually I think it comes down to how people use them. We'll come on to the personnel side in a minute, because when it comes down to hand washing, some of the data on hand washing is enough to make you weep, and you probably wouldn't be shaking anybody's hands after some of the comments I'm going to make when it comes to personal hygiene. So we'll cover that when we get to that. Lastly, with equipment, and I know I'm speaking to all of you who are converted to this anyway, you get what you pay for, and if you invest in good sanitary design of your water system or sanitary design of your vessels, you will get less microbial contamination providing you operate them correctly. If you go cheap, if you buy cheap, you cannot clean equipment that has been poorly designed adequately. So, you might save initially, but you pay big time as a result of the contamination that probably will result. So it's certainly cheaper in the long run. Cleaning equipment, the equipment that we use for this vital task of cleaning and sanitization, really is key, because if we don't look after them correctly, they do nothing more than spread contamination across the facility. I can vividly remember the smell emanating from a bucket of disinfectant this cleaner was using to clean the floor. I mean, it was enough to make your eyes literally weep. The smell was awful. The disinfectant hadn't been changed for days, and as a result, when they did take a sample, there was Pseudomonas and a few other horrible bacteria in the disinfectant. So remember, always use fresh disinfectants. People have this notion that disinfectants kill everything. Well, they don't. In fact, there are organisms like Pseudomonas and Klebsiella and a lot of waterborne organisms that can eat disinfectants and use disinfectants as a food source. So disinfectants always have to be changed and used regularly. And the more contaminated they become, the faster you have to, and the quicker you have to change them. Inspecting mops and buckets, because if you don't, sources of contamination can sit here as well. Not using what I call string mops, because they certainly are a source of contamination, and any mop has to be stored dry. So it comes back to what I was saying earlier, ladies and gentlemen, about cleaning and disinfection, and the whole process of how we look after our facilities really is vital, because as soon as this basic process of cleaning and the standards applied start to drop, we really are fighting a losing battle. But it's not a job that a lot of people like doing. It's often considered to be non-value adding. It's often, when, as I have in my career, been subjected to these sort of lean initiatives by these nasty people called consultants, where people are looking at so-called non-value adding activities. Often these are grouped together by some, the ignorant few, as non-value adding activities. Obviously we know that's not the case. So if you're ever sat in a meeting and when people are talking about reducing cleaning because the results are from the environmental monitoring are good, just remind people that the only reason those results are excellent is because of your diligence and your attention and time played or put towards things like cleaning and sanitization. So, enough said on doing the basics well. For those involved in non-sterile manufacturing in particular, probably your biggest source of, or biggest risk of microbial contamination comes from your raw materials. If you put garbage in, you certainly get garbage out. Of particular note are the materials of very high, the natural risk, natural origin materials that are high risk, and you can get any number of organisms, Bacillus, E. coli, Pseudomonas, and the like, in these raw materials. And often, as our procurement colleagues go for cheap supplies, the price we pay is a higher risk of microbial contamination that may not be detected on sampling goods in the warehouse. We all know that microbial contamination is not evenly distributed in a material, and therefore just because you don't find it in your sample does not necessarily mean it isn't there. So diligence in selection of your suppliers, making sure that your auditors who go to approve these suppliers really have an understanding of this type of information so that they can really approve those suppliers correctly, knowing that they do have good control over cross-contamination, microbial contamination, so that you are far less reliant upon monitoring and sampling as your only means of assessment, because they're not very sensitive at all. For your materials of synthetic origin, lower risk because the manufacturing processes for most of these raw materials are inherently aggressive towards bacteria. However, you've got to be very mindful of the risk of recontamination, i.e. when you open containers to sample and don't seal them correctly, or you allow moisture to get into a pack, or you don't store and transport the materials correctly, allowing moisture or damage to occur. So even though these materials are synthetic and by definition of low risk, they are certainly not zero risk, and you need to really look after them once you've got them. So those controls really are very common sense. Investing, because that's what it is, in a good supplier is really key. Improving the process to include bioburden reduction sometimes is necessary, particularly with the high contamination raw materials. So often with some raw materials, a level of pre-treatment is required to reduce those to a level, whether it be drying, whether it be through chemical treatment, sometimes using gas. The downside always is the impact that these pre-treatments or bioburden controls have on the structure of the raw material that could affect it later on. Having good packaging is obviously important, and making sure that the storage conditions are controlled and conditions of transportation are controlled. Sure, test upon receipt, but don't put too much confidence in your test upon receipt result, because the contamination is tough to find, it's not always uniformly distributed. And you know, as supply chains become more and more complex as we're going further afield for raw materials, the storage and distribution of these raw materials is becoming increasingly more important. Packaging materials that we use, so this could be card, it could be paper. Obviously, these raw materials, many of them are natural, so storage conditions are really key so that moisture doesn't get in there. There is a theme here. The importance of keeping moisture away from product materials components is really, really key, because remember, bacteria cannot survive, let alone multiply, unless they have moisture. There are some exceptions, those being things like bacillus, but in most cases, organisms require very high levels of moisture. Keep it away from them, they won't cause you a problem. Keeping packaging materials away, as far away from processing areas as possible. For those of you in sterile manufacturing, you know that it's a big no-no. You can't take paper into the production environment unless it's been autoclaved. The more of this type of material that you allow closer to your exposed product, the greater the risk of molds in particular. And obviously protecting in use, so that if you have foils used in packaging, that the foils are covered before use, not exposed to settling bacteria. Water systems. Well, we could spend a whole session on water systems alone. All of these will be common to most of us. Excellent design, recirculating the water so that it doesn't remain static, keeping potable water chlorinated for as long as possible. Often for many of our production facilities, the quality of raw water is variable. I know a facility very close to us here where they hyperchlorinate because their water is coming from a rural environment contaminated with animal excrement, so they will hyperchlorinate to get control of their potable water supply. Absence of dead legs, pipe work we've already discussed as we have done aggressive flow rates. And the types of control measures that we have in on our water systems, and it's worth just walking around a water system that you have in your facilities. You know, when you have high operating temperatures, that's above sort of 80 degrees C grate. The likes of Pseudomonas, these very typical waterborne organisms, really struggle to survive anything above 50 to 55 degrees C. However, most of our purified water systems tend to be ambient temperature, which is actually quite ideal for these types of bacteria. Regular sanitization of pipe work and of any of the unit operations listed there, whether it be carbon beds, DI units, and the likes. Sanitization, remember, is done to prevent contamination, not in reaction to it. It's just worth pausing to think about that. What I mean is so many companies sanitize, for example, their carbon beds after they've had an incident of microbial contamination. Well, that's too little and it's far too late. The whole purpose of keeping control of bioburden is to prevent the incident happening, and that can only be achieved through sanitization. Worth emphasizing again, because we're all being asked to do more and more with less and do it faster. And so often you have somebody in a meeting saying, Martin, do you really need to sanitize your purified water system every week or every 3 days because the results are excellent, so why don't you just reduce that sanitization frequency? Be mindful when you start to agree to those types of suggestions, because that's when you start to see contamination coming through. So remember, it's all about control, it's all about prevention rather than reaction after the event, because when you're trying to treat the contamination, you know very rarely are you going to remove all of the bacteria in that contaminated water system. There is going to be a small population remaining, and eventually that bioburden becomes more established and you start to have a resident population within your water system. You don't want a water system like that. I love this picture. This was taken from a museum of pharmaceutical equipment. I think it's in the Czech Republic, but a beautiful piece of equipment, not state-of-the-art, but you can just imagine the engineer standing by it saying, well, it works. We finish off, ladies and gentlemen, with what is really, really key, people. No matter how good your production environment, how good your process is, it can all be undone, and contamination can come rolling back in if your people are not paying attention to basic hygiene and basic standards of good practice. I love this picture. You can always tell a microbiologist on an aeroplane, because if anybody sneezes at the back of the aeroplane, the microbiologists are the only people that duck. When everybody sneezes, 200,000 viable microorganisms per milliliter of saliva. Just remember that. You can always, as we approach this festive period ahead of us, ladies and gentlemen, there's lots of kissing, there's lots of handshaking. Just be mindful of people sneezing, and you never see a microbiologist kiss anybody at New Year's Eve parties unless they're drunk, which is actually usually fairly common for microbiologists. But just a reminder there of here are the types of microorganisms that exist on us, on our skin, in our eyes, in our intestines, in our upper respiratory tract. The list goes on and on and on. There is actually more bacteria inside us and on us than there is of us. What I mean by that, the the number of cells of microorganisms actually exceeds the number of living cells we have in our bodies. So all of this and more really says that we are probably the biggest risk of microbial contamination to our products, without any shadow of a doubt. How do you control and prevent? We can hardly stick people in an autoclave and cleanse them that way. That doesn't go down too well. But it really does start off by employing the right people. If people at interview have dirty hands or dirt under their fingernails, or they clearly haven't washed their hair for days, and trust me, I've interviewed people like this, if they don't take a pride in their appearance, then really the attention they put towards good practices, good personal hygiene probably will be very, very low. Dress discipline, good toilet facilities. There was a recent study done, quite a horrific study done somewhere in Europe, or I won't say where, to protect the guilty, where they sampled, they took microbial samples of men, I hasten to add, leaving public conveniences, taking samples of their hands, and they basically confirmed that virtually nobody washed their hands. If they did, they were not washing their hands adequately. So it's basic, you think this is pretty basic stuff, Martin, but in reality, not many people pay the level of attention to their personal hygiene that is required, often because it's, standards drop, people don't consciously think about what they're doing. So the job of supervision and the job of the education programs that we and you run constantly through your program of recruitment and training really, really has to make it very clear that this is crucial. And make the training interesting, show people the agar plates, let them take finger samples, let them take samples of their skin, let them see the organisms that exists in these various locations. In other words, make them microbiologists, because as Bob said earlier, some of the practices that we see on facilities people wouldn't necessarily do in their own homes. Well, why should there be a difference? So some essential messages, ladies and gentlemen, just to finish off with. Monitoring and testing for the presence of bacteria is too little, and it is far too late. It's also really, really expensive. Contamination control is about prevention. So understanding the microbial vulnerabilities of your people, your process, your plant, and your procedures is really, really key. But controlling them is vital. And as soon as we allow complacency to creep in, and by that I mean, the results look good, we've never had a contamination incident, so why should we be bothered? As soon as that kind of complacency comes in, that's when we start to get a problem. And actually, when we start to see the organisms coming through, it's too late. Their populations have become established, and they become incredibly difficult to remove. So don't become complacent, and remember that GMP actually stands for good microbiological practice, because a lot of what the GMPs talk about with regard to hygiene, with regard to equipment and plant design and sanitization and cleaning, they're all there, and they're all there designed to prevent the risk of microbial contamination. And yet, it comes right back to my second comment, one of the biggest causes of recalls year after year after year continues to be microbial contamination of pharmaceutical product. So it is about applying the basics and doing the basics exceptionally well. Clearly it's not working. Clearly there is some complacency, and we need to drive that out through education, reinforcement, and supervisory discipline that makes sure the basics are being done. So, on to 2016, ladies and gentlemen. Any feedback on this webinar, as with all of the others, would be appreciated. I'm already collecting some suggestions for the program in 2016. We are going to be making more places available. We're going to be doing a few things differently. We're not going to be allowing people to block book all of the webinars because that's prevented other people from attending. So the journal that comes out in January will have our 2016 webinar program. So if you have any feedback, if you have any suggestions, please let us know. And for all of those questions, and there's been a lot of questions that are coming through, I'll get my secretaries to contact you, get back to you, we'll arrange a call, and then we can discuss your particular question in a lot more detail. So on that note, ladies and gentlemen, as we do head towards the festive time of year, have a great time with your friends and families. Don't kiss too many people, just watch who they are. But no, have a great time. Thanks very much indeed. Bye-bye.